In this session, I am going to build a simple Ohm's law simulation by using MATLAB Simulink model. First open MATLAB and launch Simulink and then select the blank model. Now look at the Simulink interface. This is the workspace where we build the model. On the side we have the library browser. All the required blocks are available here. Simulink works with block diagrams. Each block represents a real system. So first go to SimScap, electrical sources, and drag the DC voltage source into the workspace, or simply you can type it here. Just click, drag, and place it here. So this is the blocks, gives a constant voltage supply. Just double click it. See the value as 1 volt. So we can set 10 volt. So voltage is the driving force. It pushes the current through the circuit. Next, go to the electrical passive components and find the resistance there. Just click and drag it like same. For completing the circuit, we need the ground. So we have to connect the circuit components. So this represents the resistance which opposes the current flow. So for say let's set 10 ohms. Just remember, higher resistance means it lower the current. So this is the ground voltage. This is for zero reference voltage. So every SimScap circuit must have this, otherwise simulations will not run. So we need another one solver configuration block. So this is a very important block. So we can connect anywhere in the circuit. So it defines how the solver handles the physical equations. So without this block, the model will give an error. So connect it anywhere in the circuit. Now we have the circuit, and we have like in physical quantities we need a ammeter and voltmeter to measure current and voltage respectively. So here the sensors are there. We have current sensor. So the current sensors has to be placed in series with the resistance. And another component, voltage sensor. It has to measure the voltage across the resistance. So we have to connect in parallel manner. So now the sensors give the physical signal, so not a Simulink signal. So we need a converter. It's called a PS Simulink converter. Just copy and paste. So now connect the sensor output to this converter. So this converter physical signals, it converts the physical signals into the Simulink signals. So now in reality we need oscilloscopes to visualize the current and voltage. So here the black is called scope. So connect the PSM link converter output to the scope. So the scope is used to visualize the signal like an oscilloscope. So now the connections are connected in properly. So now click run. Just take the compiler to come run the program. So if anything is not connected properly, now it will shows the error signal. So now everything is okay. Then open the scope. So here we can verify the Ohm's law. So we are setting the voltage as 10 volt and the resistance will be 10 ohms. So the V equal to IR. So we can get the current as 1 amps. Right. So the current should be 1 ampere. It should match with the Ohm's law. Now change the resistance by double clicking it. Just make it as 5 ohms, just half the resistance. So it will make double the current, right? So again run the program. So we can see the current. So the current has to be 2 amps where the voltage will be same, right? So again I'm changing, I'm making the resistance as double as the initial set. So initially I'm setting the resistance as 10 ohms. Now it becomes doubled, so it will be 20 ohms. Again run the program. So the current has to be halved in the initial setting, right? So initially we are seeing the 1 amps. Now we can see 0.5 amps for the 10 volt. Now we also can set the voltage. So now for 20 volt input supply, for setting the 20 ohms resistance, we can get the current as 1 amps. So practice this, modify the values and explore more simulations. So we can also change the voltage source as from DC to AC. Just click it and just delete it. So from the library browser, so we can get the AC voltage source. Let's drag and place it here. set the voltage. So we can set the voltage 20 volt, for in then it will be 50 hertz. So we can run the program. And we can see the scope. So now we are setting the input as sine wave. For sinusoidal wave, we are setting the voltage as 20 volt. The peak to peak volt will be 20. So here will be the current will be described in the blue line. Fine. Just make it as 10 volt for our easy understanding. 1 ohm. So we can see the voltage and currents are aligned because we are setting the ohms as 1 ohm. So the voltage and current has to be 10 volt, 10 amps respectively. So now change the current, change the resistance value to achieve the change in current. Make it as 5 ohms. And run the program. Double click the scope. So here the supply will be 10 volt. We are setting the resistance as 5 amps. The resultant current will be 2 amps. In the same sinusoidal way, where we can see there is no phase shift. It was aligned with the input voltage, right? So we can have numerous components here. So we can set the any kind of circuits. For example, by using the amplifiers, we can create the applications of amplifier like integrator, differentiator, schematic trigger, or everything. For our reference, I just open the triangular waveform generator, where it combines the schematic trigger with integrator, where the schematic trigger produces the square wave output and the integrator produces the triangular wave output. So here I just browsing the components from library browser and just pick up the amplifiers, and by setting the positive feedback, so it produces the square wave, whereas the integrator produces the triangular wave because of the charging constant of the capacitors and the resistance combinations. So let's run the program and we can see the values as the visual representation. So the square wave will limited by the saturation voltage. So here it will be 15 minus 15 volt, and the triangular peak amplitude was controlled by the RC constant. So the yellow indicates the first up and up output, and second yellow, the blue will be the second amp, that is integrator output. We can also export the figure as a PNG format, and we can also save the file by using the save options. So we can explore more by using the MATLAB Simulink tool. Thank you.